2, 3. Betul. Start lah.
Tu. Apa? Jap. Rakam belum?
Okay. Assalamualaikum warahmatullahi wabarakatuh. In this video, we the group of 5 members, which include Faris Nakib, Abu Hassan, Nazmi, myself Akmal, and also Tuan Irwan Shah, will do a reflection video for the BEA student about our previous talk, which is the transformer. Okay, so to continue, I want to ask Faris Nakib, what does you learn on the previous talk? Will you proceed?
Okay, for the previous talk, I have learned that the transformer have an insulation system. Insulation system is a power transformer. Insulation system is consists of two primary component, which is liquid or oil insulation and solid or paper insulation. Okay, for the oil insulation and paper insulation, they have on the oil insulation have 4 category, which is cooler, the electric, dyeing, and information carrier. Okay, for the coolant, they have to despite heat losses. For the electric is to separate different potential part, which improve the efficiency of the paper insulation. Okay, for the third is dyeing, is to remove the moisture. And the second and the last is information carrier. Okay, for the paper insulation, they have two type, which is provide mechanic strength, and the last is provide physical insulation of conductant at a different potential in insulation system. Okay, for the mineral oil is the most common use insulation liquid, which is readily available, cheaper, long service history, and use. And the last is safe to use. The composite of the complex texture of the basic saturation hydro liquid. Okay, that's all.
Okay, thank you Nakib for that splendid explanation about the insulation system. To talk about, I will continue with the degradation of insulation system, which is something that I learned from the last talk. Next slide. Okay. The insulation system has two, like what Nakib said, which is the oil and also the paper insulation. For the oil insulation, the degradation of the oil will continue in the process, which is we call as oxidation. It will need moisture and also oxygen that come from the environment, which will increase the efficiency or the faster of the oxidation through heat, then turn the oil to water, acid, or sludge. Okay, next. For the paper insulation, there are 3 types: the thermal degradation, oxidative degradation, and so hydrolytic degradation. Just same as oil insulation, it uses 3 different types, which is heat, oxygen, also water, but it will separated the process. For thermal degradation, it will use heat to break the glycosidic bond and open glucose ring, which produce H2O, CO, and CO2. For the oxidative degradation, it will use oxygen that will produce a moisture, and also a glucose will produce in it. For hydrolytic degradation, it will produce a free glucose. So that is what I learned on the previous talk. So what about Nazmi? What have you exactly learned from the previous talk?
Tun.
Oh, no, Tun. I'm sorry. For Tun, what have you learned from the previous talk?
Okay, Akmal. So I've learned from the previous talk that it is important to have a condition monitoring of transformer. Okay, condition monitoring is a inspection and measurement of plant parameters and the recommendation of actions based on information gained from these parameters to increase the probability that the plant will continue to reliably perform its function. Okay, it is important to do the what we call it condition monitoring to prevent the corrosive sulfur. corrosive sulfur is a elemental sulfur and thermally unstable sulfur compound in electrical insulating oil that cause corrosion of certain transformer metals such as copper and silver. Why is that corrosive sulfur is such a problem? Okay, first, it can react on contact with copper and silver. From we know that the coil of the transformer uh, is designated with copper and silver. Okay. Next, it may lead to deposition of copper sulfide in the paper insulation. Okay, and lastly, the copper sulfide deposition in paper insulation will lead to weakened dielectric strength. Okay, next slide. Okay, from this figure, we can see that as the deposit build up into the insulation paper, the dielectric strength of the insulation degraded, eventually shorted between turn to turn. Okay. From this problem, what is the opportunities of the research that we can obtain from it? Okay, first, it can develop new sensor to detect corrosive in transformer. Okay, second, technique to determine the health status of winding conductor due to corrosive. And lastly, additive to slow the corrosive. That's all from me. Okay, thank you, Akmal.
Okay, thank you, Tony Renshaw, for that informative information on the sulfur test, which is really good. So now let's continue with the next person, which is Muhammad Azmi. So, what have you learned?
So from the past talk about transformer, I've learned the transformer aging assessment. The aging of transformer insulation system is an irreversible effect. So the degradation, as mentioned before from Akmal Mazlan, is one of the cause for transformer failure. Determine the insulating system condition and remain live to avoid transformer catastrophic failure. From the mind map, we could see that transformer assessment consists two types. There is physical and economic. For physical, there is divided to two: diagnostic test and thermal evaluation. Okay, next. For diagnostic test, consists three analysis. There is degree polymerization, Frenic analysis, and tensile strength. For DP, average number of glucose monomer in the polymer chain, and accepted measure of the degradation of solid insulation. And next, for Frenic analysis, this paper specimen required for DP and TS test limit their usage practically. Next, the paper insulation is breaking and generate glucose monomer, and further reaction become furanic compound. For tensile strength, there is TS. The paper age, the required is the paper age. Its strength against mechanical force decrease and 50% retention in tensile strength, transformer reach, and of life. All of these three need a paper specimen. Next. The physical test, there is thermal evaluation. Transformer aging can be evaluated using the hot spot short temperature or HST test. The increase in HST has the effect of reducing insulation life. Abnormal conditions such as overloading or exposure to higher ambient temperature can accelerate transformer aging and accordingly accelerate the time to end of the life transformer. And that's all from me.
Alright, thank you, Nazmi, for that information. So now we know that even transformer need a lot of health checkup for it to become much more functioning. Okay, so without delay, we continue with our last member, which is Abu Hassan Berazali. Okay, so tell us about what you have learned.
Okay. Hi, I am Bosan. What is I learned about the last seminar is what is the water. Water is the most content in the cellulose. More important to measure the water content is in paper than oil. So the mass of the water dissolved and in the oil and the mass of the water contained in the paper are different. One is 4 kg and one 520 kg. Okay, next video. Next slide. Okay, how to measure water in the paper insulation? There is no practical direct way of the measuring moisture level in the transformer insulation. Therefore, a wet condition may go unnoticed for the long time. This has led to indirect method of the moisture estimation. Next, direct. Direct method, take paper sample from the transformer and test the moisture content using KFT. This method are limited use in possible only during repair or tear down. Indirect method measure properties of the insulation which can be related to the moisture content. Moisture in oil measurement or electrical method, dielectric response. Next. For the direct electric response measurement, the technique available is frequency dielectric spectroscopy, pilostration or depolarization current, recovery voltage measurement. So from the picture, you can look the electrical response of the dielectric and compare to the laboratory data and model. Okay, that's all.
Thank you, Abu, and thank you for all our members for sharing what they have learned about the talk at the previous Mina. So I guess that's all from us today. Thank you.
All right, thank you. Eh,